Willingness to substitute between goods. How willing a consumer is to trade one good for another depends on the slope of the consumer's indifference curve. D q sub 2 over d q sub 1 at the consumer's initial bundle of goods. Economists call the slope at a point on an indifference curve the marginal rate of substitution, capital M, capital R, capital S, because it is the maximum amount of one good that a consumer will sacrifice or trade to obtain one more unit of another good. Lisa's marginal rate of substitution in bundle E in figure 3.4 is equal to the slope of the dashed line that is tangent to her indifference curve, capital I, at E. Because her indifference curve has a downward slope, and hence so does the tangent line, the line tangent to the indifference curve, her marginal rate of substitution at E is a negative number. The negative sign tells us that Lisa is willing to give up some burritos for more pizza and vice versa, although the marginal rate of substitution is defined as the slope at a particular bundle. We can illustrate the idea with a discrete change. If Lisa's marginal rate of substitution equals -2, then she is indifferent between her current bundle and another bundle in which she gives up 1 unit of q sub 1 in exchange for 2 more units of q sub 2, open parentheses, or gives up 2 units of q sub 2 for 1 more unit of q sub 1, close parentheses. For example, if Lisa's original bundle E has 9 pizzas and 3 burritos, she would be indifferent between that bundle and one in which she had 8, 1 fewer pizzas, and 5, 2 traditional burritos. To the right, there's a cartoon. Reads Cornered by Mike Baldwin. From 2007, Mike Baldwin, distributed by Universal Press Syndicate, Cornered.com, Cornered at comic.com. There's a gentleman in a blue suit sitting at a table, and his waiter is a gentleman. Looks very similar in a bluish green suit. In quotations, we don't have poached eggs. How about an elephant tusk? Figure 3.4, marginal rate of substitution. Lisa's marginal rate of substitution, capital M, capital R, capital S, equals dq sub 2 over dq sub 1, and her initial bundle E is the slope of the indifference curve, capital I, at that point. The marginal rate of substitution at E is the same as the slope of the line that is tangent to capital I at E. This indifference curve illustrates a diminishing marginal rate of substitution. The slope of the indifference curve becomes flatter as we move down and to the right along the curve from bundle F to EG. The figure on the horizontal axis, q sub 1 pizzas per semester, and vertical axis, q sub 2 burritos per semester. it is a curved demand curve, a marginal rate of substitution curve. It starts steep and slopes more downward and becomes more flat. F is a high point near the more vertical part of the graph on the left side, and then you have E and G. We can use calculus to determine the marginal rate of substitution at a point on Lisa's indifference curve in equation 3.1. We show that the marginal rate of substitution depends on how much extra utility Lisa gets from a little more of each good. We call the extra utility that a consumer gets from consuming the last unit of a good the marginal utility. Given that Lisa's utility function is capital U of Q sub 1 and Q sub 2, the marginal utility she gets from a little more pizza, holding the quantity of burritos fixed, is marginal utility of pizza. The partial derivative of capital U with respect to Q sub 1 equals capital U sub 1. Similarly, the marginal utility from more burritos is capital U sub 2 equals the partial derivative of capital U with respect to Q sub 2, where we hold the amount of pizza constant. We determine the slope of Lisa's indifference curve, the marginal rate of substitution, by asserting the changes in Q sub 1 and Q sub 2 that leave her utility unchanged, keeping her on her original indifference curve, capital U. Bar, I think that's a bar, equals capital U of Q sub 1 and Q sub 2. My question, if that's a bar, is because I'm not the original owner. Well, capital U bar equals capital U of Q sub 1 and Q sub 2. Let Q sub 2 of Q sub 1 be the implicit function that shows how much Q sub 2 it takes to keep Lisa's utility at capital U bar, given that she consumes Q sub 1. We want to know how much Q sub 2 must change if we increase Q sub 1 dQ sub 2 over dQ sub 1, given that we require her utility to remain constant. To answer this question, we differentiate capital U bar equals capital U of Q sub 1, Q sub 2 of Q sub, and Q sub 2 of Q sub 1. Let me repeat that. To answer this question, we differentiate capital U bar equals capital U of Q sub 1 and Q sub 2 of Q sub 1 with respect to Q sub 1. We have the derivative of capital U bar with respect to Q1 equals 0, which equals the partial derivative of capital U of Q sub 1 and Q sub 2 of Q sub 1 with respect to Q sub 1, plus the partial derivative of capital U of q sub 1 and q sub 2 of q sub 1 with respect to q sub 2 multiplied by the derivative of q sub 2 with respect to q sub 1 equals capital U sub 1 plus equals capital U sub 1 plus capital U sub 2 multiplied by the derivative of q sub 2 with respect to q sub 1, equation 3.2. Because capital U bar is a constant, the derivative of capital U bar with respect to Q1 equals 0. Since Lisa derives pleasure from both goods, if we increase one of the goods, we must decrease the other to hold her utility constant and keep her on the capital U bar indifference curve. Rearranging the terms in equation 3.2, we find that her marginal rate of substitution is capital M, capital R, capital S equals the derivative of q sub 2 with respect to q sub 1 equals the negative partial derivative of capital U over let me restart. The marginal rate of substitution is equal to the derivative of q sub 2 with respect to q sub 1 equals negative the partial derivative of capital U with respect to q sub 1 over the partial derivative of capital U with respect to q sub 2 equals capital U equals negative capital U sub 1 over capital U sub 2, equation 3.3. Thus, the slope of her indifference curve is the negative of the ratio of her marginal utilities. Solved problem 3.2. Suppose that Jackie has what economists call a Cobb-Douglas utility function, superscript 7. Superscript 7 reads, this functional form is named after its inventors, Charles W. Cobb, a mathematician, and Paul H. Douglas, an economist and U.S. Senator. The Cobb-Douglas utility function can be written more generally as capital U equals capital A, Q sub 1 superscript C, Q sub 2 superscript D. However, we can always transform that utility function into the simpler one in equation 3.4 through a positive monatomic transformation. Q sub 1 superscript A, Q sub 2 1 minus superscript A equals capital F of capital A, Q sub 1 superscript C, Q sub 2 superscript D, where capital F of x equals x to the power 1 over open parentheses C plus D close parentheses divided by A, so that A equals C over C plus D. Capital U equals Q sub 1 superscript A, Q sub 2 superscript 1 minus A, equation 3.4, where A is a positive constant. Q sub 1 is the number of tracks of recorded music she buys a year, and Q sub 2 is the number of live music events she attends. What is her marginal rate of substitution? Answer: determine the marginal utility Jackie gets from extra music tracks and the marginal utility she derives from more live music. Her marginal utility from extra tracks is capital U sub 1 equals the partial derivative of capital U with respect to Q sub 1 equals A Q sub 1 superscript A minus 1. More appropriately, it can be stated that the partial derivative of capital U with respect to Q sub 1 equals A Q sub 1 to the power A minus 1 Q sub 2 to the power 1 minus A equals A times capital U of Q sub 1 and Q sub 2 divided by Q sub 1. And her marginal utility from extra live music is capital U sub 2 equals open parentheses 1 minus A close parentheses Q sub 1 superscript A Q sub 2 superscript negative A. In this case, superscript is substituted for to the power of equals open parentheses 1 minus A close parentheses times capital U of Q sub 1 and Q sub 2 over Q sub 2. 2. Express her marginal rate of substitution in terms of her marginal utilities. Using equation 3.3, we find that her marginal rate of substitution is capital M, capital R, capital S equals the derivative of Q sub 2 with respect to Q sub 1 equals negative capital U sub 1 divided by capital U sub 2 equals negative A capital U over Q sub 1 divided by open parentheses 1 minus A close parentheses capital U over Q sub 2 equals negative A over 1 minus A multiplied by Q sub 2 over Q sub 1. Equation 3.5. Application capital M, capital R, capital S between recorded tracks and live music. In 2008, a typical British young person, ages 14 to 24, bought 24 music tracks, Q sub 1, per quarter and consumed 18 units of live music, Q sub 2 per quarter, superscript 8, which reads, a unit of live music is the amount that can be purchased for £1. That is, it does not correspond to a full concert or a performance in a pub. Data on expenditures from the Student Experience Report 2007, unitestudents.com, while budget allocations between live and recorded music are from the 2008 survey of the music experience and behavior in young people produced by the British Music Rights and the University of Hertfordshire. We estimate this average consumer's Cobb-Douglas utility function as capital U equals Q sub 1 to the power 0.4, Q sub 2 to the power 0.6, equation 3.6. That is, in the general Cobb-Douglas utility function equation 3.4, A equals 0.4. Using our analysis and solved problem 3.2, given that Jackie's Cobb-Douglas utility function is that of the typical consumer, we can determine her marginal rate of substitution by substituting Q sub 1 equals 24 and Q sub 2 equals 18 and a equals 0.4 into equation 3.5. Capital M, capital R, capital S equals negative a over 1 minus a multiplied by q sub 2 over q sub 1 equals negative 0.4 over 0.6 multiplied by 18 over 24 equals negative 0.5.